This is section 2.7 part 2, where we're going to graph an absolute value function and we're going to compare it to the parent function y equals the absolute value of x. So if you remember back in section 2.3, we compared our graphs of lines, linear functions, to the parent function y equals x, which was the most basic linear function. Now we're basically going to do the exact same thing, but with the linear function, or the parent function for absolute value, which is y equals the absolute value of x, which is the most basic absolute value function. And you can see that absolute value, when graphed in an xy coordinate plane, forms a V-shaped graph, right? And why does it form a V-shaped graph? Well, I'm going to go back to what we noted down in the previous video. All right, you guys should already have these notes down. We said absolute value is the measure of the distance from 0, right? The number of units away from 0 will be exactly the same on either side. When you graph an absolute value function, all right, you want to think of 0 as the vertex, all right? And with the parent function, the most basic form, the vertex actually lands on the origin, all right, which is 0. And so as we move up and away in this direction, we can see that this point here, which is 1, 1, is the exact same distance away from the vertex as its opposite, which is negative 1, 1. So you can see that if you were to imagine, an imaginary line passing through the vertex, if you were to fold this graph in half, this ray would lie exactly on top of this ray because they're symmetrical. All right, which is true because as you get further and further away in this direction, you're going to move the same distance in the opposite direction because you're always going to be the exact same distance away from 0. But remember, the vertex now, you'll see as we start to graph, can move anywhere within the xy coordinate plane. All right, so you always want to think of your vertex as your 0, even if it doesn't lie on 0. All points on your graph will be the same distance away from your vertex. So, this parent function does have some properties, and we've alluded to them already, well, some of them. All right, the first one is, where does the vertex lie? For the y equals the absolute value of x, all right, your vertex is going to always be on the origin. So your vertex lies on the origin. Secondly, this absolute value function, the parent function, the v, all right, opens up. All right, it's always going to open up. You'll see as we begin to graph, some of our graphs will not open up, but they will open down. So, sorry, it opens, I'm going to say graph opens up. And then lastly, all right, this V is formed by two rays, which are straight lines. All right, they do go straight. They have a quote-unquote slope, so they have a slope of 1. You're always going to go up 1, over 1, up 1, over 1. All right, in each direction. All right, so it's going to have a slope of 1. So each ray has a slope or constant rate of change, so I'm going to put slope in parentheses, of 1. So we're going to graph three absolute value functions in 3 different forms. All right, we're just going to do one form in this video, and then you'll see the rest in the next. So the form that we're going to look at, all right, takes the form y equals the absolute value of x minus h plus the value of k. All right, and the vertex, put this in red, the vertex is easily found by looking at this form. All right, the vertex is going to be h comma k. But notice this minus here and RH is positive. So this h value will always have the opposite sign of what is in the actual equation. So it'll have the opposite sign from the equation, from the h value in the equation, because the equation's negative, but the data point is positive. All right, so let's see what happens. All right, so we've got number 1. We've got y equals the absolute value of x plus 3 minus 2. You can automatically see the vertex. All right, we've got 3 and negative 2. All right, so our vertex is going to be the opposite of this number. All right, it's going to be our h. So since it's positive 3, we're going to have negative 3 and then negative 2. That's going to be our vertex, negative 3, negative 2. And then we're going to look at the number that comes in front of the absolute value bars. What number is in front of the absolute value bars? All right, because this number here is going to tell us our slope. And there's nothing there. All right, it's not a 0, all right, but it's hidden, so we're going to assume that there's a 1 here. All right, so since there's no number there, we're going to assume that our slope, or our constant rate of change for each ray, is 1. So now, to graph this absolute value, you start by plotting negative 3, negative 2. So I'm going to go negative 1, negative 2, negative 3. And I'm going to go down 2 units. So down negative 3, down 2. And my slope is positive 1, all right, because it's going to open up. All right, this number is positive. So I'm going to go from my vertex up 1 unit, right 1 unit, plot a point. Then I'm going to go back to my vertex and go up 1 unit, left 1 unit, plot a point. Because it's absolute value. So it's always going to be the same distance from, in this case, the vertex, which is our hypothetical 0. And then you can simply take a straight edge and draw a ray going off in each direction from the vertex, passing through the point that you've drawn. And that's y equals the absolute value of x plus 3 minus 2. Next, you're going to want to plot your parent function, which always has the origin, or the vertex at the origin has a slope of 1. So up 1 over 1, go back to the vertex, up 1, left 1. All right, so it's the same distance from the vertex. Again, take your straight edge, draw a line, passing through each point that you've drawn, extending from the vertex, and we've got y equals the absolute value of x. Lastly, you're going to want to compare each graph, just as we did with the linear functions. We compared our graphs to the parent function, y equals x. All right, so here as you're comparing, I'm going to start with the graph that was, or the equation that was given to me. So I can see y equals the absolute value of x plus 3 minus 2. It is the graph of y equals the absolute value of x. It's just translated. It's been moved. All right. So it's the same thing as that graph, but it's translated down 2 units and left 3 units. How do I know that? Well, I'll take blue. You can look at, always use your parent functions, your starting point, and take your vertex. Go from one vertex to the next. What happened? I went down 2 units, and I went left 3 units. That's exactly what we stated here.